Hi guys, I am Boaz, your mathematics teacher. So today we are going to learn about, I'll teach you more about algebra and something to do with the indices. Before I start, I can see so many students streaming in. I have also invited Mari from German, who is also my student in maths. Joseph, if you can join now, from Minnesota in the United States. And all my friends in Saudi Arabia, Angie, South Africa, Kefa, we are planning so well so that you do well in your studies. And to Dr. Peter Brille and all my friends in the United Kingdom. So people who are online, we are going to learn today about indices, and I take you through some of the algebra. And in many times, people always ask, why should we study this topic? And I know when you study something, let me put my alarm on, my stopwatch for recording. Now you know very well that we want to know some of the applications. Some of the applications. You may ask, why would we do this topic? And we know very well this topic of indices. Number one, people are developing the computer programs. For you to develop a computer program, it uses a lot of indices. Like in gaming, students who participate in games, if you talk about PS4, PS5, all those PSS you talk about, we need this topic of indices. And when I mean an indices, I'll be talking to stuff like a power n. So computer need those models. They need to be modeled. And especially from the games to the computer program, the other part we can talk about in exponential decay. In exponential decay, whether in medicine, whether the growth of a particular bacteria or organism, we apply the knowledge of the indices. So indices captures quite a wide field. So we talk about an example. So when I talk about here a power 1, it simply means a times a times a times a, all the way what we call, we can talk about n times. This is what I'll basically talk about here. But we know very well this topic is so much applicable even in the modeling of the population growth. Remember the year 1950, 1940, compared to now the year 2022. The population normally grows exponentially. This is how the population has been growing. So it grows exponentially. So the word exponent comes from the word index or indices. That's what we'll model here. Then I take you through quite a number of stuff. So to my students across the globe, this is just right now in an international channel, international program. So when we talk about index, if I give you a power n, it simply means a times a times a, n times. And this is a very good example. I would give you maybe, if I give you 3 power 5, what I simply mean, some students have made it in the past through our marking, even people doing the Cambridge exams, you find them taking 3 times that power. You find a student taking 3 times 5, which is wrong. 3 power 5 means you take 3 times 3 times 3 times 3 times 3 5 times. Which basically now, because 3 power 3 is 9, 3 power 3 is 9, this is 81 times 3, the answer becoming 243. So I've already told you what it simply means when we have that. Now we can be given a negative base and a positive. An example, if I come and give you negative 2 power 4 and negative 2 power 4, and I want to explain it so keenly. Now when you have within the bracket, it simply means the negative is raised to that power. And remember, the power is even. When you raise a negative power to an even power, it becomes positive. When you raise a negative into an odd power, it becomes negative. So what we come and do here, this simply means negative 2 times negative 2 times negative 2 times negative 2, which comes negative times negative is positive. That positive times negative is negative. The negative times now positive becomes, the negative times negative becomes positive. So the answer becomes positive 16. But if you have been given where the negative is not under the bracket, it simply means negative into 2 times 2 times 2 times 2. So we are multiplying the number by itself 4 times without putting negative. Why? The power was for only 2. So this your answer becoming negative 16. So when we ask you something like negative 2 in bracket and without a bracket, they provide two different answers altogether. Now let me also explain another concept after explaining this. Remember, all numbers raised to power 0 is always equal to 1. Any number raised to power 0. Somebody can even give you 1046, negative 1046 raised to power 0. The answer is always equal to 1. So that is one of the rules under the indices, that all numbers raised to power 0, the answer will always give you what? Will always provide you with 1. Now I want to introduce another concept. What if somebody provides you a negative n? Remember, when you have the negative power, it simply stands for the reciprocal. This one stands for 1 over a power n. So this is one of the properties that you need to know, that anytime you have a negative power, it means the reciprocal. An example, if I give you 5 raised to negative 2, it simply implies 1 over 5 power 2, which is equal to 1 over 25. So the negative takes care of that particular reciprocal. The other property here that you need to know, if I give you a power m, if I give you a power m, then a power n. Remember, these are bases, but in indices we learned when we are multiplying numbers, equal bases, we simply select one base, then add the powers, m plus n, which you can give example. You can even choose for yourself 6 squared times maybe 6 power 7, which simply means you pick 6, 2 plus 7 becoming 6 power 9. That is one of the rules that we need to denote here. We can talk about the other rule here. If I give you a rule, for example, a power n power m, it is a power n power m can be rewritten to be a power m power n. They can always interchange, which still means a power mn. This is called the product property. An example, if I give you 7 power 1, 7 power 1 times 7 power 2. This simply means 7, 1 plus 2 we get 3, 7 power 3, 7 times 7, 49, 49 times 7 we get 343. That is one of the rules. The other rule we can talk about, if I give you a power m over a power n. Remember, we are dividing here. You can simply take it to be a m minus n, because we are minusing the powers when we divide if they have the same basis. So these are some of the rules that you need to remember. The other rule here, if you have this, for example, we have a power m over a negative n, the denominator multiplies the numerator, which you can write a power m times a power n, which become a m plus n. So I'm moving from the numerator to the denominator. Now what if somebody provides you by a over b power n? Remember, everything is raised to power n. We can rewrite it from outside and say a power n over b power n. We just expand it from outside because they are still falling under the same bracket. The other part, somebody can give you b over a. What if it's negative n? We can rewrite this to be, remember there's another property I said, when you have a negative power, for example, a negative 1 is the same as 1 over a. So coming to this case, we can come and write a over b power n. What have I done? When the power is negative, get the reciprocal of the two variables, the a comes up, the b goes down. Now the powers turn from negative to positive. You can pause the video and at least look at it more keenly on what I mean. What if you have been given a, b, negative n? it simply means 1 over AB power what? Power n. Remember, it was put under the bracket. Now, what if I give you a question, an example I give you here to be 4 x negative 4 y power 5, then I put it to be cubed. Remember, when you take a letter times a variable, this is a very important concept that many students should note. An example, somebody giving you 4 ABC. Mathematically speaking, it means 4 times A times B times C. So in this case, it means 4 times x negative 4 times y power 5, then everything is cubed. Remember, you have to take care first of the negative power. So this one we can rewrite to be 4 times 1 over x power 4. I'm taking the reciprocal because of the negative power, times y power 5. Then I raise it to be power 3. Then here we are going to write it is 4 times 1 times y power 5 over x power 4. Remember, everything is raised to be power 3. Then the power is raised to each and every individual. So this power multiplies the power of every stuff. So 4 power 3 means 4 times 4 times 4, which is 16 times 4 we get. What is 16 times 4? 64. Then y. Remember the power products. So 3 times 5 we get y power 15 over 3 times 4 we get x power 12. So that becomes the solution to this particular index problem. What if somebody provide you with a problem, an example, n negative 2, m putting over 7, m negative 4, n negative 3. If you have this particular question, how do we go about this? Remember, the negative powers go down, the positive power remains up. So in this case, what are we supposed to do? Instead of having this, I will have the m, all the negative powers from the down must come up. So we are going to have our m times, since this m is negative 4, it comes up, times m power 4. The n is also negative, it comes up, n power 3. Then this, we had already singled it out. We put over, 7 was a number. Then this m remained here. So whatever that comes down is n. So it becomes n squared. Because it was the negative go down, they interchange their positions. So what are we supposed to get here? M power 5, because we add the powers, n power 3 over 7n squared. Okay, so the n squared goes here 1, so we get our answer to be m power 5 over 7. So this will be the solution to the entire problem. The only basic I want you to learn that the negative powers, they interchange positions. Because I'd already said, if a is negative 1 is the same as 1 over a. But if it is 1 over a negative 1 is the same as a. So that is a very important concept that you can remind yourself. Now let me give you other examples here. If somebody provide you with 32 power 2 over 5, it is very important to understand this concept. If somebody provides 32 power 2 over 5, remember the lower part stands for the root, the upper part stands for the power. So how can we rewrite this? We can rewrite this to be 32 power 1 over 5 times 2. Because 1 over 5 times 2 is 2 over 5. So we get the fifth root of 32. Then we square our answer, which we can come and write. It is 32, the fifth root. Then we do what to our answer? We square our answer. The first thing, we can break them separately. And I want to teach you another short way of getting, either you get the square root or you get the cube root or the fourth root. You just take that number because we want the fifth root of 32. So you can write 32 there. Then you factor out 2 gets here 16, 2 gets here 8, 2 gets here 4, 2 gets here 2, 2 gets here 1. So we have 1, 2, 3, 4, 5. If it is the fifth root, out of 5 we pick 1. So we pick only 1, which is 2. So means the fifth root of 32 is 2. Then remember your answer was supposed to be raised to power 2. Then 2 squared is supposed to be 4. So that's how we deal with such stuff. Let me explain. If somebody comes and asks you the nth root of a, it can be, that n can represent 2, it can represent 3, can represent any stuff. Remember this sign, we normally call it a radical. That symbol of the square root, we normally call it a radical. Because this one can be rewritten to be the a power 1 over n. So this side, we call it the radical form. The radical form. Then this side, we call it the index form. I just want you to know, how do we change from roots into fractional powers? By simply taking 1 over that. If it is 3, we write 1 over 3. If it is square root, remember in square root, we do not need to write that 2. So we leave it that form. So this is called the radical. This is called the index. This is the index form. And this is the radical form. What else do we need to know? This a here, we normally call it in mathematics a radicand. This is a radicand, index form, radical. Then this is the radical form. Now, how do we work out this? I would like to give you a simple example. If somebody comes and asks you, what is the square root of 64? I'll begin with a very simple number. This you can write to be 64 raised to power half. So we change it from the radical form into index form. Then the 64 you have here, we write it somewhere, then we subdivide it by its factors. Knowing very well that 2 gets here 32, 2 gets here 16, 2 gets here 8, 2 gets here 4, 2 gets here 2, then 2 gets here 1. If it is square root, we pair them 2, 2, 2. So we can pair these 2. We can only pair them and pick 1 at each stage. If you are finding square root of 64, write your 64 in as a product of its composite factors. Then pair them 2, 2 if it is square root. If it is cube root, pair them 3, 3. So in this case, what do we have? 2, 2, 2. So the answer becomes 2 times 2 times 2, which provide 8. So mean the square root of 64 is 8, using this method. Alternatively, if you had written it to be 64 power half, and you know very well your 64 is how many 2's? 1, 2, 3, 4, 5, 6. Which means 64 is 2 power 6, close the bracket, power half. Because this half is still here, the 64 is what we've expressed as 2 power 6. Then you use power products. A half times 6 is 3. So the answer becomes 2 power 3, which is 2 times 2 times 2, which still give you 8 as the square root. So we have different ways of working it out. Yeah, when we have been asked to get, we have 17, 28. Somebody is asking you to find the square root, okay? Somebody is asking you to find the square root. Remember, we can always write square root in the form of power half. So all fractional powers always means the roots. So you take it very easy. Just take your number 1728, then you divide it by the multiples of that number. You can start with 2, you get 864. 2 goes into that 432. 2 gets it, let me say it is cube root. What if they ask you to get the cube root? We've done so many square root. 2 gets here 216. 2 gets here 108. 2 gets here 54. 2 gets here 27. Then 2 can't get in 27. So we go to the next multiple. 3 gets here 9. Then 3 gets into 9 3 times. Then 3 ones. So you see how we have beautifully done it. People preparing for the checkpoint, especially in the year 9 or what we call grade 9. Now we are going to pair them 3, 3 if it is the cube root. Out of the 3 numbers, choose 1. You choose only 1 and you choose 1. So the answer, you take those numbers 2 times that 2 times that 3. So the answer becoming 12. So the cube root of 1728 should be 12 by going to those basics, which is very easy. Don't just write the answer. You have to show the methods. Many times I teach my students across the entire globe. You must show the steps. You must show the procedures. Okay? So the answer becoming 12. So that's how we get it. Okay? There are some other questions that has just been asked by some students. So what if you have a number like 24, a power 3, b minus 8, all over 6, a negative 5b, then everything is raised to negative 2. I'm taking you through your indices in the middle school and even up to A level. So make sure whenever you see a negative power, that's what I'd say, the negative comes up. They interchange positions. An example, just before we solve it, we can come and say by the definition. By the definition. Because you go to the rules of maths. Just like I taught you the previous lesson. If you go to a court of law, you provide the defense according to the law. So according to the constitution of maths, they definitely say if you have A over B raised to a negative, that's by the law of maths. They are not my word, they are the principles. So you will come and write it to B over A power 2. Remember, I've interchanged the numerator and denominator, and then the power turning from negative to positive. That is step 1. Then you also need to know another law. If you have 1 over A negative 5, you can write it to be A power 5 over 1. At the same time, if you have A negative 5 over 1, you can write it to be 1 over A power 5. So those are mathematics rules. Remember, the moment a student has written this, it is what will guide you to get that answer by using those laws. So what did you learn today? Whenever it's a negative power, you take the reciprocal of the number, not the power. Let me show you further. If it is A power negative x over y, you can rewrite it to be 1 over A power x over y. Do not change y over x. I know many students are cross. I'm not just talking to Kenya. In Uganda, I have so many students in Canada, in Germany, in the United States, in our online program. And I find a student, when they see the negative, they write it to be y over x. That is wrong. It is everything. You take the reciprocal of everything, then the power turning from negative to positive. Please remember these concepts. Now, let me wrap these particular laws, these rules, then I may walk you baby steps to the answer. Now, what am I supposed to do? Anything negative down must come up. So, first of all, in your exam, highlight the negatives. Then they must change the positions. So, we are going to write 24 a power 3. Remember, being negative, it will have to be displaced down. And being negative must come up. So, this a negative 5 now becoming a positive. Are we good? Then we have our 6. Then this b was there. But remember, the b negative 8 now has to come down times b power 8. Remember everything, do not forget, they were supposed to be raised to power negative 2. So I've started within our bracket. Now 6 cancel once, 6 goes here 4. So it's like having 4 times a power 3, a power 3 times a power 5. What did I teach you by the rules? If you have a power n times a power m, is the same as a into m plus n. We add the powers when we multiply them having the same basis. Now what am I supposed to have here? 3 plus 5 we get 8. All over we have the b which is power 1 times the b power 8. They have the same basis. So what do? We add the powers. You see, it is so sweet to solve a maths problem. So we get b power 9. So remember, everything was still to power negative 2. Guys, let me walk you very closely to what we are supposed to get. Let me wrap this end. You can pause the video for you to understand better. Now, having a negative, what did I say? We reciprocate everything. So the down part becomes b power 9 over 4a power 8 power 2. Now somebody will ask, why did I interchange? Because the power was a negative, according to our mathematics rules. Then the power multiplies everything inside. So this power 2 times this 9, we get b power 18. This power coming here, so it's like 4 squared, we get 16. 8 power 8 squared again is a power 16. So this is the solution to this gigantic problem. So please always learn to follow laws, follow rules. Subscribe to my channel. I always take you step by step, the baby steps, until you reach what you are supposed to do. You see how easy it is? Some of these questions have just been sent to by some of our friends in the United States. People are doing mathematics. It was grade 9. Yeah, he was a grade 9 student sending this. Now the other one that was sent, that what if you have x power 2 plus y squared square root? How do we go about it? Very simple. What you're supposed to do, you will write it x squared plus y squared power half. Let me use a numerical value to explain. If somebody comes and asks you 4 plus 9, the square root, you cannot come and say you find the square root of 2 plus square root of 9, 3, you get 5. That will be wrong. That is inaccurate. That cannot happen. Why? It cannot happen because we are not getting the product. It only happens when we are multiplying. So I'm doing it so deep, so passion, and I know by the end of the day our students, they are going to learn that. So you can only rewrite this to be 4 plus 9, you get 13 under the square root. And you know the square root of 13 can never be 5. Are we good? So we just leave it in that way. Or you can rewrite it to be 13 power half. But you cannot solve it beyond that part. Now in this case, this is the answer. Do not get the individual roots because it is a plus. When it is a plus or a minus, do not. A plus or a minus, do not. Are we good? I hope now those students, they are now happy so that they are going to score high grades in their exams. Guys, welcome to Kenya. I welcome all my United States students and all the other countries to Kenya. In Kenya, we do a lot of maths. Now, if we have 8 power x, then we are asked to get the 10th root of 8 power x. Very simple. You simply come and write 8 power x in bracket, power 1 over 10. And we can break it. Because 8 is 2 times 2 times 2, then times that x. So this the same as 2 power 3 x power 1 over 10. So this multiplies this, which is 2 power 3 over 10 x power 1 over 10. In fact, we leave it that way. That becomes the solution. Okay? I see your questions now. I'm answering them one by one. But they're so sweet. You see how enjoyable they are. Now, there was another question here. I was sampling across. This one was sent from German. Now the question, I think it was Mari who first came up with this idea of indices. Okay? Now 32, x power 9, y power 5, z power 12. Then they're asking you to find the fourth root. See how beautiful this question is. You can rewrite it to be 32 x power 9, y power 5, z power 12. Then you raise everything to power quarter. So all my students, listen to that. Power quarter. And if you want to do well in maths, please go back to basics. Go back to concepts. An example, there was a time I was in a certain town. Then I lost my way to the building where I was supposed to meet a friend of mine. So I tried looking for different ways. I could not retrace it. So you know what I did? I had to go back to a place that I knew. one of the landmarks in that particular town. Then I started walking again from that place. Then it took me few minutes before I arrived. So it means you always go back to basics. Don't start finding your way from where you don't know. You cannot locate your position from where you do not know. So that's all about maths. Now let me make it even much more. These are just appetizer. Now 32, we can consider this to be 2 gets here 16, 2 gets here 8, 2 gets here 4, 2 gets here 2, 2 gets here 1. So how many 2's do we have? 1, 2, 3, 4, and 5. So we get to power 5, x power 9, y power 5, z power 12. In bracket, power a quarter. See how they are very easy. Then remember what I taught you initially. If you have a power n, power m is the same as a power nm. This is by the rule because the power multiplies the power. So these are all powers. These are all bases. Yet they are in exponent form. These also are power. So take power to multiply all power. What is quarter times 5? You get to 5 over 4. What is quarter times 9? X 9 over 4. What is quarter times 5? Y 5 over 4. What is quarter times 12? Z 3. So this is how we can leave it. This is still an answer, but you can still rewrite it in different formats. You can rewrite it in different formats. Remember, you can still come here and write this 2 power 5 to be 2 times 2 power 4. Then this x power 9, you can write it x power 8 times x power 1 because you add the powers. This y power 5, you can write y power 4 times y. Then times z, sorry, let me wrap that, z power 12. Then we multiply everything by power quarter. This is the answer we got here, but we would have still rewritten this in that format. So this power will multiply this. This power will multiply this. So that's how we get the solution in any given indices. Now there was another beautiful question we were given. What is the square root of y power 7? Now this is what you are supposed to do. Square root means you can write it to be y power 7 power half. We just play around with the numbers. Which half can come in? 7 remains outside. Okay? Can we write this to be y times y power 6 into power half? Because y times y power 6 the same as y power 1 times y power 6. So it is y power 7. Then every power half times 1 we get y power half. Y a half times 6 we get 3. But remember, power half means the square root of y. This is times y power 3, which you can write your answer to be y power 3 times y. So this is the simplified root form. You see how easy. So we just break it down. Don't say, I don't know, teacher, the maths is hard. Maths is not hard. So we simply break those particular stuff. So easy. Okay, allow me to, I know there are some students copying this. Yeah, just write. Now the other part we have here to be somebody giving you 625 power 3/4. So remember this. Allow me to wrap this, guys, and this beautiful part so that I may write and I may explain to you with clarity. Now what did I teach you? I taught you guys if you have a power m over n is the same as the lower part means the root, the upper part means the power. So it's like getting the nth root of a raising to power m. This is a very important rule which you can apply here. You say the lower part means the root, the upper part means the power. So we write the fourth root of 625, then I raise my answer to power 3. Then what did I teach you about roots? Very simple. Whether it's power 5, don't worry. Just go and write that your number. Then try to prime factorize. Can 2 get there? No. 3, no. 5, yes. 5 gets here. 1, 25. The next one is 5, 25. Next one is 5, 5, then 5, 1. And if it is fourth root, out of 4 we pick only 1. So you get the fourth root here becoming 5, then the answer you are supposed to raise to be power 3. 5 times 5 times 5 is 125. So this becomes the answer to that simple equation.